In the last video, we talked about how to convert from raw scores to z-scores and how to convert back from z-scores to raw scores. In this video, we're going to talk about how to use those z-scores together with the standard normal table to find out things about the distribution. Okay, so this is a standard normal table. You can't read the values, but here we have three columns. In the first column, column A, we have a list of z-scores from 0.00 all the way to 4.00 in 1/100ths increments. Okay, so it's going to go 00, 0.01, 0.02, all the way up to 4.0. In the second column, we have B, and that's the area in between your z-score and the mean. Okay, B is going to be in between your z-score and the mean. If you have a negative z-score, it's going to be here, between your negative z-score and the mean. So that's B. Then you have column C, and that's the area beyond the mean. So if you have a positive z-score, that's the area over here to the right. And if you have a negative z-score, it's the area over here to the left. The values in columns B and C are given in proportions. So for example, here we have a z-score of 0.1, and the B is 0.0398, and the C is 0.4602. So these are proportions. For them to be useful to us, we're going to convert them to percentages. We can do that by multiplying this number by 100 or by moving the decimal place over 2. That would give us a value of 3.98% or 46.02% for C. So what that tells us is that if you have a z-score of 0.1, right, that's here, then 3.98% of all people in the data are between you and the mean. So you're pretty close to the mean. There are only 4% of people between you and the mean. It also tells us that 46.02% of people are above you, have higher scores than you if you have a z-score of 0.1. Okay, so that's what this table is used for, is to tell you the percentage of the population that has a higher or lower score, or what percent of the population is between two different scores. Okay, so to use this standard normal table, there are 5 steps. The first step is to convert all the raw scores to z-scores, okay? Because the standard normal table uses z-scores. So that's always going to be step 1, convert all the scores to z-scores. Step 2 is draw a normal distribution, like one of these two, with all of the values that you are concerned with in the question. So here we have a bunch of values, right? So we have, again, IQ, and our mean is 100, and our standard deviation is 15. So we have 4 raw scores. Somebody has an IQ of 115, somebody has an IQ of 70, somebody has an IQ of 94, and somebody else has an IQ of 124. I've done the work of converting these first 3 values into z-scores. Let's do the fourth value together. So we're going to convert 124 as a raw score into a z-score for this distribution. To do that, we're going to do z equals 124, which is the raw score, minus 100, which is the mean, divided by 15, which is the standard deviation. Okay, so 124 minus 100 is going to give us, of course, 24. And 24 divided by 15 is 1.6. So that means that our z-score for our IQ of 124 is 1.6. So we have converted all of our z-scores, all of our raw scores into z-scores. That's step 1. Step 2 is to draw a normal distribution with the values. Okay, so here we're going to draw a normal distribution. We're always going to put a line in the middle. We're going to label that y bar, which is the mean, and it's going to have a z-score of 0. The mean always has a z-score of 0 because it is 0 standard deviations away from the mean. In our data of IQ, the mean is 100, so we're just going to write 100 above y bar. Okay, let's say that I asked you what percent of people has a higher IQ than 115. Okay, so that's a raw score of 115. So I'm going to draw a line for 115. We know the line goes on the right side because 115 is greater than 100. So 115 goes here. And we know that that has a z-score of 1. So we're going to write 1 here. So in this chart, 50% of all of the scores are going to be below the mean. Because normal distributions are symmetrical. So 50% is on this side and 50% is on this side. So this side will always have 50%. Then in our standard normal table, the area between your z-score and the mean is B, column B. And the area beyond your z-score, that's greater than your z-score if you have a positive z-score and less than your z-score if you have a negative z-score, is C. So I asked you what percent of people has a higher score than 115. So we need to shade in the region that is higher than 115. That's this whole region here. Okay, that's step 3. Shade in the region that you're interested in. Okay, step 1 was convert all the raw scores to z-scores. Step 2 was draw this distribution. Step 3 is shade in the area you're interested in. Okay, step 4, determine which column in the table I need. So I'm concerned with this shaded area, which is C. So column C for a z-score of 1. So I'm going to go look up my values in the table. That's step 5. So I'm going to look for a z-score of 1, which is right here. And I'm going to look for column C. Okay, so that gives me a proportion of 1.1587. I'm going to convert that to a percentage. That's 15.87%. So the answer is 15.87% of the population has a higher score than 115. So that's how you would find that score, okay? Now, suppose I asked you, what percent of the population scored lower than 115? So I'm going to do the same thing. I'm going to draw a normal distribution, okay? Y bar is always going to have a z-score of 0. 115 is still higher than 100, so I draw a line over here. I write 115 above it, and its z-score of 1 down here. 50% of scores are here. This is B, in between the score and the mean, and C is beyond the score. This time I asked you, what percent of people scored lower than 115? Okay, so which areas do we shade in? Well, we need to shade in this area because that's lower than 115, and also this area because that area is also lower than 115. So we need to find two values. We need to find the B column for a z-score of 1, and we need to add 50% to that. Okay, because this shaded area is 50%. So I'm going to look for B for a z-score of 1. So here is our z-score of 1, and the B column has a proportion of 0.3413. So 0.3413. I need to convert that to a percentage, right? So that's going to be 34.13%. So that just gives us this area, the area in between our score and the mean. In order to get the full answer of how many people scored lower than 115, I need to add 50 to that. And that's going to give us 84.13%. So here we have 84.13% of all scores are going to be lower than 115. And 15.87% are going to be higher than 115. So that's how you use these steps and the standard normal table for a positive z-score, right? So this is a z-score of 115. Let's do an example with negative z-scores. So with negative z-scores, you're going to use a drawing that's slightly different. You're going to use this illustration instead of this one. Okay, so let's do how many people scored lower than 70 as their IQ. Okay, so we do the same thing. We draw a little illustration. We label the middle y bar. It has a mean of 100 and a z-score of 0. This time, we're going to draw a line on the left side because 70 is less than 100, right? 70 goes to the left of 100. And that has a z-score of -2. Okay, so in this case, C is over here, beyond our z-score. B is in between our z-score and the mean, and the right side is now 50%. All right. I'm interested in how many people scored lower than 70. So that's going to be this region here. So I'm going to shade in this region. That is a C column, right? Because that was C, for a z-score of -2. So now I'm going to look on my chart for a z of -2. Oh, I need to flip the paper over. All right, -2. In the standard normal table, there are no negative values. You just look for the z-score that is the same number but positive. The only difference is B is going to be this region and C is going to be this region instead of this region and this region. So there, you use the same numbers, the same values. It's just that B is here and C is here instead of B being here and C being here. That's the only difference. So we're going to look for our area, our z-score of 2. Here it is, z of 2, column C. So that gives us a proportion of 0.0228, which we're going to convert to a percentage, which tells us that 2.28% of all scores are going to be lower than 70. We'll do one more with the negatives. How many people scored higher than 90? Okay, so here's 100, that's our mean. That has a standard deviation of 0. 90 is less than 100, so it goes to the left. And 94. 94 is less than 100, and it has a z-score of -0.4. Okay, C is here, B is here, and 50% is here. So which regions are higher than 94? That's going to be B and 50%. So we know that we're going to add B plus 50%. So let's find B for a z-score of 0.4. Okay, so we're going to look for 0.4 on our chart, and B is going to be 0.1554. 0.1554, which we're going to convert to a percentage, 15.54%, and we're going to add 50 to it. Okay, because we need to add the B to 50 to get this whole region. And that's going to give us 65.54%. So 65.54% of all the people in this data set are going to be above a score of 94. Alright. So that is how to do simple scores, percent of scores below and percent of scores above if you have negative z-scores and positive z-scores. But sometimes you're going to get asked, what is the percentage of people that are between two values? So, there are two different things that can happen. Either you're going to have what is the percent of people between two values. One is a negative value and the other is a positive value for z. So I'm going to ask you, what percent of people scored between 94 and 124? So here we have 100, which is our mean, which is a z-score of 0. 94 is less than 100, so we're going to draw a line here, label it 94, and give it a z-score of negative 0.4. And we're going to draw a line here for 124, because that's above the mean. And we're going to label that 1.6, because that is its z-score. So this region here, we are interested in the two regions that are between 94 and 124. Alright? So that's going to be this region here. This region is B for this z-score. Okay? So this region is B for a z-score of negative 0.4. And we need this region because that's also between 94 and 124. And that's going to be B, but for this z-score. So what I'm going to do is I'm going to do B of a z-score of negative 0.4, and I'm going to add that to a B for a z-score of 1.6. So I'm going to look up those two values, okay? B for 0.4, that's going to be 15.54%, okay? And B for 1.6, which is on the back, is going to be 44.52%. And to get the region in between those two numbers, all I do is add those up. So that's going to be 6, 1, 1. So 60.6% of all scores are between 94 and 124. Okay? But what about if I asked you what scores are between 124 and 115? Both of those scores are above the mean, right? Both of those scores are above the mean. So here we're going to draw a line for 115. 115, which has a z-score of 1. And we're going to draw a line for 124, which has a z-score of 1.6. So I'm interested in the area between those two, which is this area here, right? How do I find that? Well, this area from here to here, from 0 to 124, is B for this z-score, right? And this area from 100 to 115 is B for this z-score. So to find this region, I need to do this whole B minus this smaller b. So that's B for a z-score of 124, for a z-score of 1.6, which corresponds to a raw score of 124, z of 1.6 minus b for a z-score of 1. So I'm going to find those two values. Well, we know from our last problem that a b, the column B for a z-score of 1.6 is 44.52. So we know that that's our first value up here, 44.52%. Now all we need to do is find B for a value of 1. Okay, so we're going to look at our chart for 1, and B is 34.13%. Alright, so now to find this region, we subtract those two. And that's going to give us 10.39%, okay? So that's how to use the standard normal table to find values above a score, values below a score, and values between two scores. That's it. I hope this helps. Thank you.